Welcome to class 9 lab static routing. So let's build this topology. So I have just started all the machines in the lab. So let's start with PC1. So PC1 we need to give the IP of 10.0.0.1/24 and its gateway will be 10.0.0.254. So verify the IP configuration, show IP. So 10.0.0.1/24 and it has gateway. So this is all the configuration we need to give on PC1. Let's go to PC2. So for PC2 the IP will be 192.168.0.1/24 and its gateway will be 192.168.0.254. So save the configuration and verify the configuration. Okay, so we have given 0.1/24 and gateway is 0.254. Let's go to R1. So when we start the machine it will be in this mode. So first we need to enter it to the next mode, which is enable mode. In this only show commands will work. So let's verify if this has any interface configuration. For that we will issue command show IP interface brief, or in short show IP int brief br. So there is nothing configured yet. So let's go ahead and configure Ethernet 1 first. You can type configure terminal or in short conf space t. So first we need to go into interface configuration, then Ethernet 1. So in this topology Ethernet 1 IP will be 10.0.0.254/24. So the command will be IP address. So now we got an error stating that configuration will be ignored as Ethernet 1 is not a routed port. So why this is happening is we are using multi-access switch. So by default it will be a switch all its ports. So for that what we will do, we should make it as no switch port. So we are just telling that it's not a switch port, it's now be a routed ports. To give the previous command you can just do up arrow to get the previous commands, and let's enter it again. So now there is no error. So let's go ahead and configure Ethernet 2, this topology. So no switch port and IP address will be 1.1.1/30. So why we took /30 between R1 and R2 is because we only need 2 IP addresses in this link. Okay, so that's why I used the /30 network. /30 will have total 4 IPs: 1.1.0, 1.1.1, 1.1.2, 1.1.0, 1 and 2. So total 4 IPs. So we don't use the first IP and last IP, which is .0 and .3. Okay, so it will have total 4 IP addresses: 1.1.0, 1.1.1, 1.1.2, 1.1.3. So we don't use the first and last address in any network. So they have special purpose that we will discuss in future classes, but for now all you have to do is you should not use the first and last address. So that's why I took 1.1.1 and 1.1.2. So Ethernet 2 we have given the IP. So let me type exit. Okay, so now we have given the. So next part is to avoid confusion, I want to give it a name. So currently you see the name of this router is localhost, right? So we can assign names to the devices. So in this case this is the command I'm using. So now you can see, so that we can differentiate where we are on. Okay, so let's go ahead. So as we given the IPs for 2 interfaces, let's look at the routing table. Show IP route. So we have routes for 1.1.0/30, 10.0.0/24, because if you see the symbol beside the route, it is C, means connected, means those routes are learned based on the interface configuration. And you can see below IP routing not enabled, because this is a multi-access switch. By default it won't run the routing, so we need to type IP routing. Okay, so now if you verify the configuration again, show IP route, now we don't see that error. So let's save the configuration, write memory or WR space mem in short. Okay, so R1 configuration is completed. Let's go ahead and do the R2 configuration. So same steps, enter enable mode. Okay, then configure terminal. Let's change the host name first, then enable the routing, then assign the interfaces. So Ethernet 1 in this topology, it should be IP address 192.168.0.254/24. Okay, this is all for that one. Next we go to Ethernet 2. So switch port IP address 1.1.1.2/30. Okay, so now save the configuration, write memory, then verify the routing table. So now it knows two routes, both are C, means connected based on the interface configuration. Let's go and try to ping from PC1 to PC2. So will it work? No. Let's see why it won't work. So I'm pinging PC1 IP. So when you ping that, you see some response. You might be thinking that it's a successful ping, but it's not. As you can see, the reply is coming from 10.0.0.254. The message is stating that 10.0.0.254 destination network unreachable. That means whoever has this IP doesn't know how to forward this ping request. So basically when this packet goes from PC1 to R1, so let's look at the interface to confirm. So 10.0.0.254. So if you go to message on PC1, 10.0.0.254. So what this IP is mentioning is that I'm not able to say reach the destination network. So why? Because as it is a router, when the packet comes to the R1, the destination IP of the packet is 192.168.0.1. So it will check its routing table. Does it fall under any of these two routes? No. So it doesn't know where to send the packet. That's why it is replying back for that ping request to PC1 stating that, okay, you are trying to send a packet to PC2. I received that, but I don't know where to send. So I'm just giving you a message that I'm not able to deliver the packet. Okay, so that's what this message means. So let's go ahead and tell R1 using the static route how to reach the PC2 network, or how to forward the packets with having destination IP of 192.168.0.0/24 network. Okay, so configure terminal, IP route 192.168.0.0, destination prefix it is asking in the different format. So this is also /24. Okay, so we are telling the router that if you want to route any packets falling within this range, you need to send it to 1.1.2 based on this topology. Okay, so let's go back, save the configuration and verify the routing table. So now we have three routes, two flagged with C, means two connected based on the interface configuration, and another one is with S. So if you check here, S stands for static. So we added a route statically stating that this particular network 192.168.0.0, it needs to send it to next hop, which is via 1.1.2 on Ethernet 2. So with this command, we are telling the router 1 that if you receive any packets falling within this range, send it to 1.1.2. How it will send? As discussed in the theory class, R1 will send ARP request for 1.1.2. So R2 will reply back with its MAC address. So it will put it in the destination MAC address field. Okay. Router is not changing the destination IP here because the packet is going from PC1 to PC2. Okay. So only destination MAC will change, and the source MAC, as it is going from the Ethernet to, it will put the source MAC of Ethernet to of its, okay, R1 Ethernet to MAC. So now let's try to ping. Will it work? No. So now we are getting different message. So what we are getting is PC1 is sending the packet to 192.168.0.1, but it's timing out. Means it has sent the packet and it went to R1. Now R1 knows where to send the packet. It sent it to R2. And once the packet goes to the R2, R2 will also know where to send because it's already a connected route. So it will send it to PC2. So PC2 received the packet and now it needs to reply back. Now for the reply packet, PC2 will construct the packet as source IP is 192.168.0.1, destination IP is 10.0.0.1. So it is in the different network, so it will send it to its gateway. Now the packet comes on R2. Okay, once packet comes to the R2, what is the destination IP of the packet? It is 10.0.0.1. Does R2 know how to send this packet? It doesn't know. See, it is only have two routes. It knows about 1.1.0 and 192.168. Both are connected based on the interface configuration. So the request packet went all the way to PC2. When PC2 replying back, reply packet came to R2, but R2 doesn't know where to send because there is no route in the routing table. So now we need to tell R2 that how to route packets for this particular network. So if it is receiving any packet for 10.0.0/network, it needs to send it to, what is the next hop? 1.1.2. Okay, sorry, 1.1.1 is the next hop. Okay, so let's verify the routing table again. Okay, so now we can see three routes. Two are connected, one is static S. So to send any packets to this network, it needs to send it to 1.1.1. How it will know the MAC address of 1.1? It will just send the ARP request. Okay, so let's save the configuration. So now if we go back to PC1 and if we do the ping, it should work. Okay, now you can see it is successfully sent 5 ping packets, means 5 ping requests went successfully and it got received 5 replies as well. So how much time it took for the each packet in this GNS3 topology to go from PC1 to PC2 and PC2 back for the reply to PC1? It's 49 milliseconds. Okay, so if you try to ping different IP, you will get different responses. For suppose I am trying to ping 0.2. So what is the expected response is timeout, because there is no 192.168.0.2. The packet will go to R1. R1 will forward it to R2 based on the static route, and R2 will try to send ARP request. But nobody will respond because PC2 has 0.1 and there is no other PC connected to R2. Okay. For suppose let's try to ping 8.8.8. So what is the expected response? Once the packet goes to the R1 check fill the routing table and it won't find anything for 8.8.8. So it will notify back to the PC1 stating that I don't know how to reach 8.8.8. See, So 10.0.0.254 is replying that I don't know the destination network, I'm unable to reach. Okay, that's all for this lab. You can try to do the second assignment I explained in the lab, adding R3 in between R1 and R2. See you in the next class.